Okay, so as we enter Unit 4, we're going to start talking about inverse trig functions and equations, but in order to do that we need to review inverses. So first of all, what is an inverse? Graphically, it is a function that has a reflection across the line y is equal to x, and this is from Algebra 2. And algebraically what we do is we switch the x and the y in an equation or in a coordinate, and if it's in an equation, we're going to solve for y. Okay, so the notation for an inverse function is written as the following: f to the negative 1 of x. So this right here indicates the inverse, that negative 1 power. So I'll highlight it in a different color. And this is not the same as a reciprocal function. This is not the same, okay, as 1 over f of x. These are not the same. Okay, so I'm going to give you an example. Here we have f of x is equal to x cubed. So algebraically what we have here is y is equal to x cubed. You're going to switch the x and the y, so you would say that x is equal to y cubed, and then you need to solve for y, so we're saying that the inverse is the cubed root of x, which is something that you should know. You could write it like this: f to the negative 1 of x is equal to the cube root of x, okay, or x to the 1/3 power. These are the same thing. So if we have a set of points, meaning our x comma y, we might have something 0, 0. Okay, so this is coming from this. We could have the point 1, 1. If I plug in 2 for x, I get 8. Let's try a negative here, negative 1, negative 1. So then what's going to happen is, for the inverse, when I switch x and y, we still get 0, 0. Okay, that doesn't change anything. We still get 1, 1. We still get negative 1, negative 1. Okay, but something like this would get the point 8, 2. Okay, so we're switching x and y. So now if we look at our function graphically, okay, if we're taking this, which is the x cubed, we have 0, 0, we have 1, 1, we have negative 1, negative 1, we have the point 2, 8, so it's 1, 2, 3, 4, 5, 6, 7, 8, all the way up there, 2, 8, or you would have negative 2 and negative 8, so I'm going to say it's like down here, so it's the same. So then you have this. Okay, so this is f of x is equal to x cubed. Okay, now what we're going to do is we're going to reflect this graph in the line y equals x. It's going to look like this. Okay, so this is y is equal to x. That's our line of reflection. Okay, and if you notice here, these points are falling on that line. Okay? So then we know that 0, 0 stays the same, 1, 1 stays the same, negative 1, negative 1 stays the same, but now I have 8. So this is 1, 2, 3, 4, 5, 6, 7, 8, 2. So we know that the other one would be, if this was negative 2, negative 8, this would be negative 8, negative 2. So, I don't know, all the way out here, down here, so it's going to go like this. So that means the graph goes like this, and I'll draw in the dotted line. So I'll highlight it with the highlighter here. That's going to be my inverse. So this is x to the 1/3 power, or the cube root of x. Okay. So the theorem for composite functions of inverses is, if you put the inverse inside the actual function, you should get x. For example, f of f to the negative 1 of x would be equal to f. Remember, the inverse was the cubed root of x. put this into my f of x function, which is cubed. So this would be the cubed root of x cubed is x. Proven. Now if you do it the other way around, the answer should still be x. Meaning, if I take the original and I put it in the inverse, I should get x. So we know the inverse is the cubed root. The original was x cubed. Put this in for x in the inverse. The cubed root of x cubed is x. The domain and the range for inverse functions. The domain in f of x becomes the range in the inverse, and the range in the original becomes the domain in the inverse. Meaning, any characteristic that belonged to x now belongs to y, and vice versa. The biggest piece here that we need to take away is that not all functions have inverses that are functions. Okay? In order for an inverse to exist, it must be a function that is considered 1 to 1. Now you may or may not have covered this in Algebra 2 Honors. Okay? So not only must it pass the vertical line test, but it must also pass the horizontal line test. Okay? So, if a function is not 1 to 1, okay, meaning it does not pass the horizontal line test, okay, we can restrict the domain and force it to be 1 to 1 in order to find the inverse. So this right here proves that you have a function. This right here proves that, whoops, you have 1 to 1. Okay. So, for example, here we're going to use a parabola. Y is equal to, or f of x is equal to x squared. So we know we have 0, 0, we have 1, 1, we have negative 1, positive 1, 2, so this is 1, 2, 3, 4, 2, so you have this point, and you have this point. So I'm going to sketch my parabola. Okay, so you need to ask yourself, do I pass the vertical line test? Yes, pass. Meaning you could draw all these vertical lines and you would only get one x value to y value. That's a vertical line test. The question is, do we pass the horizontal line test as is? If you draw a horizontal line here, you do not pass. So this is a fail. So that means that the function is not 1 to 1. But if we were to restrict the domain, so let's say we restrict the domain right here. So let's restrict domain. And we're going to go from 0 to infinity. It's infinity. Okay, why are we choosing 0 to infinity? Because everything is positive, meaning we have no negative x values. Now, do we pass the horizontal line test? So, what we have here, okay, would be f of x being equal to x squared, where you have your domain for any x value greater than or equal to 0. This is a domain restriction, so remember we said we were going to restrict the domain. Okay? With that, this is our graph. We have 0, 0, 1, 1, 2, 4. Okay, so here, here. This will be my original function with the domain restriction. Okay, so now what I do is I switch x and y. Okay, and I would say y is equal to x squared, x is equal to y squared, y is equal to the square root of x. This is positive because we're dealing with all values greater than or equal to 0. So this is going to be my inverse, which means now I have 0, 0, 1, 1, and now I would choose 4, 2 because it's easy. Square roots. This is my inverse. Okay. 1 to 1 passes the vertical line test, passes the horizontal line test. Okay? So, if your function's not 1 to 1, we restrict the domain. A similar concept is used for sine, cosine, and tangent, and these are all functions, but they are not all 1 to 1. Okay? Therefore, we have to restrict the domain. Okay, this is all review.